Now, the law of inertia says a body in motion tends to stay in motion. Now, you have a rotating disc, it will keep rotating. You have a stationary disc, it will stay stationary. So, you have a disc on an axle. And on this axle, you have two permanent magnets making you know, like a pitchfork at the end. Two magnets and the axle of the disc. Then on the other side you have two stationary magnets. And you get that discs beginning to rotate. Now I see this on the internet too. But that's not how it's fixed. That is not how it is set up. The way it was set up there is that they keep the four magnets, pairs of two on each side, opposite sides, keep coming together and going apart, coming together and going apart, faster and faster. And that rotates the disc. Now, how would that happen? How would you have four magnets set up like that to rotate a disc? You know that opposite poles attract, and like poles repel. So what would be the polarity of each magnet, each of the four magnets in that 2x2 matrix or array? Now can that be realized? Probably it can be realized. Now you can rotate that axle also using springs, right? Now if you're able to rotate it using springs and magnets, you have to make sure that all the vectors are adding and not fighting against each other, because using 5 springs is not always better than using 2 springs, depending on what you need to do, right? As you can see from some of the spring activated rotary discs. Right? There are physical laws, electromagnetics, you know. Now if these 4 magnets set up in such a way that they're pumping each other, they're fighting each other, they keep punching each other faster and faster, and the disc keep rotating faster and faster, will it ever dampen? Those magnets will go weak after a while, right? Right? Now, how do you keep those magnets charged? Now, that thing is probably like the design of a motor. Unlike you know, the rectangular conductor and the magnet going in and out, a bar magnet, and the wire rotates. It's the same principle. So now if you're able to do that, you can have some feedback into the magnets to keep those magnets charged, or to fine-tune the speed of that rotation, right? How do trains levitate and travel 300 miles per hour? Magnets push it. Magnets push it. If a magnet can push a train 300 miles per hour, why can't it rotate a lousy disc? It's how you arrange it, right?